Our world is colourful. Colours surround us. But how do these colours come into being? How do we perceive them? And why do objects appear coloured at all? That's exactly what this video is about. To understand this, we first need to take a step back and take a closer look at white light. Let's once again look at the visible spectrum. Here we can see the individual spectral colours, from violet to red. What we do not see here, however, is white light. The reason for this is simple. White light is not a single colour. It is created by the combination of all spectral colours of visible light. When white light passes through a prism, these individual colour components become visible, just like in a rainbow. White light therefore does not exist as its own spectral colour. We only perceive it as white when all wavelengths reach our eyes together. This brings us to a crucial question. How do humans perceive colour in the first place? The light that enters our eyes hits light-sensitive cells in the retina. For colour vision, so-called cone cells are responsible. Humans typically have 3 different types of cones, each reacting to different wavelength ranges. The S cones respond most strongly to short-wavelength bluish light. The M cones respond to medium greenish wavelengths. And the L cones respond mainly to long-wavelength reddish light. However, these cones are not tuned to a single specific colour, but to overlapping regions of the visible spectrum. Only through the interaction of these signals does our brain interpret a colour impression. Colours are therefore not an objective property of light itself, but arise through physiological perception and are always subjective. But why do the objects around us appear in different colours at all? The colour of an object is determined by which parts of the incoming light it reflects and which parts it absorbs. When white light, a mixture of all spectral colours, hits a red object, most wavelengths are absorbed. Only the red portion of the light is largely reflected and reaches our eyes. That is why the object appears red to us. If the same red object is illuminated with blue light instead, the red light component is completely missing. The blue light is absorbed, very little light is reflected, and the object appears very dark or even black. A white object reflects almost all spectral colours evenly. A black object, on the other hand, absorbs nearly all incoming light and reflects very little. Which wavelengths are reflected or absorbed follows clear rules. To better understand these relationships, we use the colour wheel. The colour wheel is a simple representation of visible light and the relationships between its colours. Colours that lie opposite each other on the colour wheel are called complementary colours. For example, red and cyan, blue and yellow, or green and magenta. These colour pairs have a special relationship and play a central role in colour perception and colour mixing. When light of a certain colour hits an object or a filter, the complementary colour is often absorbed. A red filter allows red light to pass through and absorbs the cyan component. Complementary colours can therefore either enhance each other or cancel each other out, depending on whether light is added or removed from the spectrum. Colours do not arise from light alone, but from the interaction of the spectrum, the material, and our perception. How we can use this knowledge and deliberately combine colours is what we'll explore in the next video. There, we'll take a look at colour mixing and the difference between additive and subtractive colour mixing. Thanks for watching.